My name is Benedikt, and I'd like to share a story with you, a story that happened pretty close to here in Berlin, but half a century ago. And it is about the astrophysicist John Richard Gott. That's the friendly fellow that you see here on the picture. And so he visited Berlin, and he saw the Berlin Wall. It was separating West Berlin from East Berlin, and at that time in 1969, it had been around for 8 years already. And John Gott asked the question, for how much longer is this wall going to be around? Now, obviously, he didn't know, and no one else did know, probably one of the hardest questions to answer ever. So what he did, he created a heuristic or a principle to give a probabilistic estimate of the longevity of the future lifetime of the Berlin Wall based on nothing but its current age, 8 years. And for this to work, he made one important assumption. He assumed that the time he was visiting the wall was no special time at all. He was just randomly arriving at some point in the lifetime of the wall. So what he did then was to say, okay, if I arrive at about a quarter of the lifetime of the wall, and that is 8 years now, that means 3/4 are still ahead of me. And 3 times 8 is 24 years. Now, as I arrive randomly here, the probability of being there before that point in time is 25%, just uniform distribution. And in the same way, if I arrive at 3/4 of the wall's lifetime, then those 8 years are 3/4, meaning that I have still ahead 2 2/3 years of the wall's lifetime. So, and again, there's a 25% probability. So, I have in the middle 50% probability that the wall will be there for longer than 2 2/3 years, but no longer than 24 years. So if you do a little bit of the math, then what you will get is this distribution function, so a very simple function. And you see there this T current, that is 8 years for the wall. All you need to do in order to get a complete distribution of the future lifetime of the wall is to divide T by T plus T current. Very simple. So let's see how this works in Python. So we have the function here, and we can just compute any arbitrary probability interval that we want. Let's say we want to be a bit better. We can do like so. And obviously there's nothing special about the wall in this case. You can use Gott's principle to predict the lifetime of pretty much everything, provided that you arrive at some random time during the lifetime. And all you need to know is the current age. Isn't that amazing? Well, there's no free lunch, of course. Let's move to the left a little bit. Let's be really sure. Let's have a 90% confidence interval. So now the wall is going to be around for another 150 years. That's a pretty broad confidence interval. Well, no free lunch. You only had to plug in 8 years. That's cool. So, and now the question you really want to know. For how long is Python going to be around? So, 29 years, is that correct? It's 29 years old. So, you want to be really sure? Okay, 1.5 years to 550 years. Thanks a lot.